Next thing we want to do is to put these points onto the graph. Okay, the graph should end up looking like this. So we take our table of values. Our first point you'll see is a point 0, 0. So we put 0, 0 onto the graph here. There's 0, 0. Okay, so I mark it with a wee X. Right, and the next value we're going to draw is sine of 30. Okay, so 30 is our x value and 0.5 is our y value. So 30, okay, you'll see my graph is going up in 30, each box here is 30 degrees. So 30 is there and there's 0.5 there. Okay, my next one is 60 degrees, which is 0.87, then 90 degrees, which turns out to be 1, and then 120 degrees, which is 0.87, 150 degrees, which is 0.5, and you continue to put these dots in where they should go, and you should get a nice smooth sine curve when you join them up. Okay, now please join them up to make a smooth curve and not with jaggedy straight lines. Okay, now the graph continues on beyond 360 degrees, okay, but it starts repeating itself at this point. Okay. Right, then we move on to cos, and we're going to draw the graph of cos x, okay, and put all these numbers into our next graph, right, like this. So when we plot our first point of the cos graph is actually 0, 1, okay, so there's 0, 1 here on my graph, 0, 1, then it'll be 30, 0.87, 60, 0.5, 90 is 0, 120 is minus 0.5, 150 is minus 0.87, and 180 is minus 1. And then we continue to put the dots in, and we should end up with this curve, slightly different, but again it continues beyond 360 and just starts to repeat itself. Okay, so that's the curve I'm looking for cosine. Okay, now important things to note about these curves once you're drawing them. Important things to note about these graphs is that we have a maximum value of 1 in the sine graph, and the maximum value occurs when x is equal to 90. Okay, so there's my maximum value on the sine curve there, and it's occurring when x is equal to 90, maximum value of 1. It's got a minimum value of minus 1 down here, and that occurs when x is equal to 270. So a maximum value when x is equal to 90, maximum value is 1, and a minimum value of minus 1 when x is equal to 270. Now the next thing I've noted down is what we call the period of the graph. Now the period of the graph is how many degrees the graph covers before it starts to repeat itself. Okay, so we see that there is one full wave from 0 to 360. So we say that the period of the sine graph is 360 degrees. Okay, now similarly with the cosine graph, it has also got a maximum value of 1, but this occurs now when x is 0. Okay, so the maximum value occurs when x is 0. And we've got a minimum value here of minus 1 when x is 180. And we actually have a second maximum here when x is 360. Okay, so it's actually got two maximums of 1 at 0 and 360, and it's got a minimum when x is equal to 180. And again, the period of the graph, well, the graph goes from 0 to 360. So 0 to 360 here before it starts repeating itself. So the period of the graph is also 360 degrees. Okay, right, on to our tan graph. Right, so our table of values should look like this for tan. Okay, with these undefined values at 90 and 270. Okay, now we call those our asymptotes, right, and they're explained a wee bit more in the other videos. Okay, so 90 and 270 we've got asymptotes. So when you're drawing the graph of tan x, I want you to draw in the asymptotes to begin with. Okay, so the asymptotes are occurring at 90 degrees. Now I've taken a different colour of pen here and I've put in a sort of dotted line there. So draw a vertical dotted line at 90 degrees and one at 270. Now our table of values only went to 420, but there would actually be an extra asymptote in here at 450 degrees that's probably worth drawing as well. Okay, so draw in those three asymptotes to begin with and then start to plot our points. So our first point on the tan graph is 0, 0. Okay, so the tan graph in the first point is 0, 0. And there it is on my graph there, 0, 0. The next one is 30, 0.58. So when I draw that on my graph, you'll notice that I've gone up to 3 here on my graph. So 0.58 is round about there. Then 1.73 is round about there. Okay, and then the next point to draw is minus 1.73 and minus 0.58 and 0 and 0.58 and 1.73 and then etc, etc. Okay, now those points alone don't really help you draw the tan graph, to be totally honest. You have to have a slight amount of awareness about what happens at the asymptotes. So when you're joining up these points, again, please don't use straight jaggedy lines. Try and draw a nice smooth curve through those points. Now what happens to the graph as it approaches the asymptote is it gets closer and closer and closer. Now this will just get infinitely higher, this tan graph. It'll just keep going and going and going. And as it gets further up, as it gets taller and taller and taller, this graph, it gets closer and closer and closer to this asymptote, but it never touches that asymptote, okay, because the tan of 90 degrees is undefined, right? So we can't get the tan of 90 degrees. It cannot touch this line. It gets as close as it possibly can, infinitely taller, but it never touches it. And what happens when it goes beyond 90 is it jumps down here, and again, when we're drawing this graph, this line here doesn't touch the asymptote. It's very close, it gets closer and closer as we go further down, but it doesn't touch it. It gets as close as it possibly can, but it doesn't actually touch. And again, nice smooth curve through the points, and the graph gets closer and closer and closer to the next asymptote at 270. Again, doesn't touch. Okay, now the graph should look like that when you draw it. Okay, getting closer to those asymptotes. Now, things to note about the tan graph. The asymptotes obviously are important. The asymptotes occur at 90 and 270. I've only put them in because they're the ones between 0 and 360. So there is another one at 450, which is on the graph. Asymptotes at 90 and 270 where the tan graph is undefined. Now, if we look at the period of the tan graph, that is the number of degrees for one single wave to occur. Now, if you look, the easiest way to see that, where that happens, is between 90 and 270 there. You'll see there's a single tan wave between 90 and 270 degrees. Now, that means that the period is 270 minus 90 degrees, which is 180. Okay, so between 90 and 270, which is effectively a period of 180 degrees, and then the tan graph repeats itself. Okay, right, so if you could get a nice drawing of these three graphs here, that will do you for today. Into your notes, papers attached to help you draw them, and we'll look a wee bit more detail at some transformations next day. Okay, right, bye bye.